Before we talk about telescope, equipment, or specifications, we need to identify something more important: direction. Because astronomy is not a collection of products, it's a system built on light, physics, and constraints. Hello, everyone. This is Farzad, and welcome to the first episode of Astronomic. I'm an electrical engineer and I hold a PhD in this field. My background includes power systems, power electronics, EMI and EMC, and a little bit of telecommunications. But alongside engineering, I have always had a strong interest in astronomy, in understanding what happens far above the Earth's atmosphere. As I spent more time in engineering, something gradually became clear to me. Very different physical systems often follow the same mathematical structure. For example, a mechanical mass spring system and an electrical inductor capacitor circuit are physically different. One involves motion, the other involves charge. But mathematically, they follow the same principles, basically the same differential equation. Similar observation changed how I looked at astronomy. Astronomy is not separate from engineering. It is built on electromagnetics, optics, mechanics, signal processing, control systems, and many other fields of science. Once you understand that, you stop asking, what is the best telescope? And you start asking, what is the best system for my goal? That shift from product thinking to system thinking is the foundation of astronomy. The purpose of this channel is simple: to approach astronomy with engineering clarity, to think in terms of systems, trade offs, and constraints to avoid impulsive decisions. Now, let's step back and ask something more fundamental. Before buying equipment, before discussing specifications, we must answer one simple question: what do you actually want from astronomy? Because different motivations lead to different equipment, different expectations, and different strategies. To make this clearer, I have simplified the entry points into 5 common gateways. The gateways are the scientist, the engineer, the observer, the measurer, and the educator. Now let's briefly examine each one. Number one, the scientist. They are motivated by understanding, and they are interested in how stars form, what black holes really are, how galaxies evolve, how cosmological models are constructed, and etc. The priority here is knowledge and physical laws. Equipment actually is secondary. Number two, the engineer. They are motivated by system performance, and they are interested in telescopes, mount mechanics, optical design, tracking precision, sensors and data acquisition, and etc. For this person, equipment selection becomes a system optimization problem, just like engineers. Number three is the observer. They are motivated by direct experience, and they're interested in seeing Saturn's rings, observing lunar detail, capturing a nebula, and etc. Here, realism and simplicity often matter more than technical perfection. Number four is the measurer. They're motivated by data and repeatability, and they're interested in tracking asteroids, monitoring variable stars, recording occultation, and etc. For them, stability and calibration matter more than visual aesthetics. And finally, number five is the educator. They're motivated by perspective and sustainability, and they're interested in teaching, inspiring, building a long-term structured hobby, and etc. For them, reliability and clarity dominate over complexity. Most people actually are a combination of at least two of these doors. And astronomic will not attempt to serve all of them equally from day one. Instead, we will build systematically. And now, let's talk about a quick word about the name. Astro is slightly modified, as you can see in the logo, into Austro. The AUS here is a reference to Australia, the country I migrated to around 9 years ago from Iran. And I value both cultures a lot. In the future, actually, I may create Persian versions of some episodes. But for now, we focus on building a solid foundation in English. Now let's move on to the astronomic roadmap. For the first 3 months, basically the first 12 weekly episodes, we focus strictly on fundamentals. Not hype, not brand ranking, not top 10 lists. We begin with the physics of light and optics. We will explore light as information, aperture and resolution, focal length and image scale, focal ratio and exposure efficiency. Then we move into environmental and mechanical constraints. We will discuss atmospheric seeing and sky conditions, mount fundamentals and tracking stability. After that, we focus on the sensor and signal chain. We will cover camera basics and sampling theory, signal, noise, and integration time, and stacking and calibration. And finally, we turn to architectural and system level decisions. We will study optical designs and telescope system trade-offs, most likely as two separate episodes. Only after building this foundation will we begin exploring different equipment configuration, applying what we have learned in a structured and practical way. Because equipment selection should be the result of understanding, not the starting point. By the end of these 12 episodes, you should be able to ask, does this equipment set match my goal? Does it match physics? Does it match constraints? And you may find yourself far from asking impulsive questions like, does this look impressive? So this was basically our 3-month roadmap. Now let's move on to the documentation and methodology of astronomic. Because this channel is built on structured thinking, the project will be documented. The full system planning and technical breakdowns will be available in our GitHub repository with the link I placed down below. Every week, I will publish an astronomic weekly journal summarizing decisions, adjustments, and lessons learned. Therefore, this is not just a YouTube channel. It is a long-term documented engineering approach to astronomy. I also aim to upload one main episode every Tuesday, give or take 1 or 2 days. And during the week, I will also publish short videos focusing on single micro concepts. So this is episode 1. This is not about buying equipment. This is about defining direction. Because without direction, equipment is just metal and glass. But with clarity, it becomes a system. And that's where astronomic begins. Welcome to the journey.